session now. The third session is with Mr. Kiran Chitnis, Senior Director, Druva, and we are going to talk about how secure is your data on cloud. To give you a brief introduction of Mr. Kiran, Kiran has been in the industry for the last 16 years. He started his career with a startup named Infonox, acquired by TSYS. Kiran wears a lot of hats. He has worked through the system administrator and he's moved to virtualization leader. He moved to cloud in 2009-10 when cloud computing was just evolving. So we are going to all set to hear you, Kiran, now. Thank you. Over to you. You're on mute, Kiran. You're on mute.
Yeah, thanks, Anamika, for pointing that out, and thanks for the introduction as well. So let me bring up my presentation to speed it up. So hold on. All right, quick check, Anamika, if you're able to see this one. Hey, Anamika, can you give me a heads up if you are able to see this one?
I can see you. Yeah.
Okay, am I audible? And I'm guessing my presentation is up. So I'll start with this topic which talks about.
The screen is not up.
Yeah.
Okay, let me check. Is it up now?
No. Yeah. It's coming. Right.
All right, thank you. Thank you for that. Is it up now? Just a quick check again.
Yeah.
Cool. So I'm going to talk about how secure is your data on the cloud today. And I'm going to spend like the next 15, 20 minutes to go over this. And the last 10 minutes I'll use for any Q&A that may come through. So brief introduction, Anamika has already introduced me, so I'll keep it a one-liner. So I've been with Druva for 5 years and I head the cloud operations and DevOps function as a senior director. And I've been in this industry for the last 16 years. Right? Quick introduction about Druva. So we heard a lot of speakers talk about data protection. So we are a SaaS provider who does data protection for the cloud era. A quick stat check, we have 700 employees globally, and we have about 7 global offices, 5,000 plus happy customers, and we've hit 100 billion in revenue last year, and our valuation has exceeded $1 billion. About our cloud scale, we have about 150 petabytes of storage in the cloud, which we manage, right? And that means that we do about 5 million backups per day, spread across 2 million global endpoints, which are pretty much at our customer sites. From a security standpoint, we are FedRAMP compliant. We have SOC 2 HIPAA, among other compliances. And from our customer services side, we have industry best CSAT and NPS scores. We've been awarded and named the best by analysts like Gartner, Stevie, Forrester, etc. Right. About our global scale on the cloud, we are present in about 16 regions, and we also have a foot in the federal space in the United States, which is a separate cloud available from Amazon Web Services. And we are a single cloud hosted SaaS provider. So we are pretty much 100% on the cloud and on AWS itself. As you can see, there are some regions where we do not exist, but it would not take us more than a week to be there, right? So I'll jump into the crux of the matter, talk about cloud security, right? So here's a quick Dilbert who goes over to one of his colleagues and says that he wants to move things into the cloud. And as it stands, there is a sense of fear, right? Because it is assumed that if you put things in the cloud, it is available widely over to the public, and strangers would be able to access your data. And then you have somebody say, I trust encryption way more than, and I've blanked it because it was a bit offensive. And that's pretty much the thought process that everybody has, right? When you think about putting things in the cloud, it is assumed that it is going to be on the internet and publicly accessible. So let's talk about cloud security responsibilities, right? So we heard terms like IaaS, PaaS, and SaaS, right? So in a cloud environment, there are essentially various stakeholders, right? So when you look at the entire ecosystem, you have infrastructure as a service vendor, which is somebody like Amazon Web Services. Then Amazon itself provides you certain platform services. Let's say Elastic Beanstalk is a platform as a service, right? And then you have your SaaS, which sits on top of this infrastructure and platform, right? So the ownership of security of each of these components is owned by different folks, right? The security of the infrastructure is obviously by your vendor, which cuts down significantly on your responsibilities. The ownership of PaaS is also on the vendor because PaaS is again a hosted service which you consume as you stitch your SaaS into the PaaS, and that's where your focus should be mainly on the SaaS offering that you have in the cloud, right? And that's where the term cloud service provider or SaaS provider comes into picture. That's where we stand, right? So what are the services that are available on the cloud, right? So on the whole, you have certain compute and databases. You have certain storage services, which are like Elastic Block Store, Amazon S3, where you store, which is an object store, and then you have metadata stores or metadata services like DynamoDB. Then you have networking services like Amazon Internet Gateways, VPCs, the routing, and all things that talk about talking to each other. And then you have identity and security. Although Amazon has like thousands of services, I'll kind of put my focus only on these when I go through this presentation. Right. And last but not the least, the most important one is management and governance, which also provides you like audit capabilities, governance capabilities that lets you monitor your security posture as such. So when you talk about security, security is built on top of several blocks, right? It is just like a set of Lego. When we look at security, you start from authentication, authorization, encryption in transit, encryption at rest. You look at application security, monitoring, BCDR, and finally your certifications that qualify all of these put together, right? Just for keeping this talk focused on data security, I'll only talk about encryption in transit and encryption at rest and certain networking concepts here, right? So this is how, in general, cloud services, right? So the top box is where a customer on premises who is consuming your cloud service. In this case, this is Druva's backup service, which is hosted 100% on the cloud, and customers would be backing up their data into our global regions wherever they are closest to. So what is your scope for data security in this model? You have a network, which is your public and private. That's what controls data in transit. You have storage services like S3, DynamoDB, RDS, EBS, right? That's where you look at data at rest. And then you have management and governance of your data. And at the same time, services that offer security natively, right? Things like KMS, which is key management service. So let's look at network security when we start with. So typically you'll have users that are consuming your cloud service via the internet. So your first obligation or first strike at security should be that all of your services that are hosted should be served via SSL, right? And SSL is a legacy term. It's now switched to TLS. TLS stands for Transport Layer Security. And especially in TLS, older protocols like 1.0 and 1.1 are now obsolete. So always make sure that you start off with TLS 1.2 at the bare minimum, right? TLS 1.3 is already in the works, and it should be a global standard soon, right? It started in 2018, and I think the movement will catch up. But the importance of this is that your data in transit is always encrypted. The integrity between senders and receivers is always maintained using strong cryptographic methodologies. Sometimes, for a compromise of performance, there is a tendency to let internal services communicate non-SSL. We do not believe in that. We believe even internal services are subject to scrutiny, and therefore we should make sure that all internal services are also talking TLS 1.2 at the bare minimum, right? And this is all of services that are consumed, and this is what constitutes your data plane, right? When we extend that to a management plane, you'll have a Bastion host, you'll have metrics, logs, and events. So when you connect into your cloud service, always connect your on-premises to your cloud using a strong VPN, start with an IPsec at least. And then when you talk to your management versus your control plane or your data plane, always have services that will allow you to communicate between these services securely and offer TLS at the bare minimum. Right. So that's like a quick topology of communication. There is not much to it, but it is always important to make sure that there is no unencrypted traffic going between yourself or your customers to the cloud, wherever it may be. Right. Moving on, a quick checklist. Use TLS 1.2, like I always said. Communicate across IaaS services via APIs and should only be driven by HTTPS. Do not fall back on HTTP in interest of performance. HTTPS is the way to go. And provide services on the internet only if required. Do not put everything out there. The moment you put something out there on the internet, you are subject to attacks, and potential hackers will want to compromise your system and gain unprivileged access. Right. So only put things that are necessary to be serving internet-bound traffic on the internet. For all practical purposes, put everything in the private subnet, which means that you are shielding and reducing your attack surface on the internet. Let's look at storage security, right? So when I look at storage security, I look at the block stores, the object stores, the metadata stores, and anything that deals with data in our cloud. So start with encryption at the minimum. This is a very busy slide, so I'll condense it for you. Never store unencrypted data. That's the theme of this message. So the way you do it is have a data encryption key. Don't create a data encryption key and store the data encryption key as is. Put a dual factor, which is put the data encryption key in an envelope and encrypt it with a key encryption key, which is commonly known as a key wrapping key, right? So there is a two-factor level of authentication. And at the same time, do not use the key and do not use the key encryption key and store it as is, right? Put in a customer ownership into the key. So in this case, the way we do it is we use a customer password which encrypts the key encryption key, which in turn encrypts the data encryption key, right? So at no point of time we store any of these secrets in the database. There are tokens generated out of this, which are decrypted at runtime in memory, and then are used to encrypt data objects that are in the IO space, right? Or in the input-output space. So the theme of this is that, always have a two-factor method of encryption, or at the bare minimum, have some sort of encryption that will prevent undue or unprivileged access to your data, right? What does that give you? In our context, we never have access to customers' data, because without the customer's password, which they choose at customer creation times, nobody can decrypt any key that is used to encrypt data objects, right? So even if we store 150 petabytes of data, it's not that we can go and watch what those 150 petabytes are. They are stored as blocks, which are encrypted using keys that are unique to every customer. And those customer keys can only be decrypted by the customer admins who own the passwords to it, right? A similar solution, if you want to see it in the non-enterprise space, you can look at a service called LastPass, right? LastPass provides you a service to store your passwords encrypted on the internet, but you cannot, or LastPass employees cannot necessarily decrypt your passwords or view your passwords unless your password is compromised by them. Moving on, in the same space, in the data space, never let your admins get into any service in the data plane, right? And therefore, nobody can have access to in-memory decryption or things like that. Moving on to storage security, storage services are basically accessed from your tenant, which is called a VPC, and there would be some compute instances that are basically connecting to the backends, whether it is the object store or the metadata store, which is very relevant to our use case. Always stand with the privilege or always stand with the principle of least privilege, right? So when you communicate across services in the cloud, you have an option to choose either an access key and a secret, which is similar to a username and a password, or you can have temporary credentials, which are driven by role-based access controls. So when you create roles and policies that permit or prevent, give access or grant access to inter-service communication, always stand with the principles of least privilege for the APIs, and that will give you an added level of security at each stage of the way. So even if a service A gets compromised, you will have various levels of defenses that will help you prevent undue access to customer data. Right? Never let static secrets be stored unencrypted on disk as well, because they are prevent to hacks. Use something like a parameter store, which will help you manage components there. So one quick party trick, if this is too much of tech for you, AWS provides a native service called Key Management Service. Now, Key Management Service by default provides you encryption for all storage services, right? So whether it is EBS, whether it is RDS storage, whether it is metadata store, or anything and everything that is out there as a storage service, at a click of a button, you can encrypt all data by choosing it to be backed by KMS encryption. Now, when you choose KMS encryption, you have two options. One is a customer managed key or a vendor managed key. So you can choose either. Both of them work. The power is that it is backed by FIPS 140-2 validated modules. It has first-class support for all AWS services, and there is inbuilt audit compatibility with trails, etc., that are available to you. Things that are required as a part of compliance, where you have to auto-rotate, destroy, and all of it can be automated because KMS can also be leveraged using APIs, right? And lastly, when you look at storage security, this is a quick checklist. Security is only as strong as its weakest link, right? And in a tech world, the weakest link would be the people behind it. So therefore, always prevent your storage or your data from people directly. So don't have management console access to accounts or services that host data. Automate all security operations. Follow the DevOps culture for secrets management, resource administration. Have 100% infrastructure as a code. Always audit, remediate, and cycle your analysis, right? So if you find gaps, keep auditing it, keep monitoring it, and remediate gaps that you identify. Routine exercises for business continuity and DR plans form a part of the compliance. So don't use compliance as a checkbox. Always make sure that these processes that are built for getting your compliance certifications are tested time and time again, right? And this pandemic is a great example of when it stood the test of time and was leveraged by many companies to go work from home, right? As a minimal benchmark, at least get SOC 2, PCI, and HIPAA, depending on the industry that you're in. SOC 2 is the bare minimum that you should get certified for data security. Right? And here's an important quote that Werner, who's the CTO of Amazon Web Services, said in reInvent, right? Dance like no one is watching and encrypt like everyone is, right? It's a very powerful quote. And when the vendor of the largest IaaS vendor or a member of the largest IaaS vendor says that on a public stage, he really means it, right? So always ensure that nothing stays unencrypted out there on the internet. So last, as a parting slide, who owns security? So it's a two-factor ownership. AWS owns the entire infrastructure, which is compute, storage, database, hardware, physical security, all of it, right? And you as a cloud service provider are responsible for customer data. So just because S3 is secure does not mean that you can go ahead and assume that you will put everything out there as a public S3 bucket and assume that it will stay secure out there, right? And as a norm, you can actually leverage on your cloud vendors certifications and build certifications for or compliance for your SaaS by leveraging what already exists, right? So cloud provides you that flexibility of getting certified, because you don't have to worry about hardware security and all of it that is already certified by AWS. So you can piggyback your entire certifications for SaaS based on what your cloud vendor already has, right? So with that, I have exhausted my 20 minutes of talk. I'll quickly jump into Q&A and let you ask me any questions if you have. So there's a question from Arvind who says, where to learn more about cloud technology, cloud security, any books or resources? I would recommend going into courses like Udemy has a ton of AWS courses, right? Start with those. There is at least at the bare minimum before you get into security and details of it. At least get the cloud foundation basics right. So, right, AWS has a foundation essentials course, and there is a path to certification for AWS on cloud security, and that's a good start or a good way to progress in your career if you are serious about security as your future. What if advanced security broke up? What could be done to prevent it via emerging technologies? So, interesting question, right? So, when security always is a multi-layer of implementation, like I showed in my architecture diagram. Every step of the way, there has to be a fencing which will prevent or restrict access across for lateral movements, right? And at the same time, there is a strong emphasis on things like CloudTrail. So anytime any event or a security incident happens, you should have a SIM system which will get you alerts. And at the same time, you can automate the entire fallback. For example, if somebody opens up a security group in your infrastructure, that should trigger a SIM event, which will essentially trigger an automated Lambda function, which will revert whatever was changed. So no matter how many times an attacker would want to change a configuration, make sure that your configuration or your setup in the cloud remains immutable, right? And those things are very much possible with emerging technologies. So what if an admin system is attacked? So if you saw my diagram, the admin system is only able to access systems in the management plane. Now, management plane would hold things like logs, metrics, events, or things like that, right? A management plane will not have access to the data plane. So no matter what happens, if at all an attacker is able to move from an admin system into the cloud, let's assume that he is able to do that, your restriction would still prevail, right? You will not be able to move in from your management plane into your data plane to compromise customers' data. And that is very important. That's where you build a wall and make sure, like our global infrastructure, we have nobody who can SSH into our systems. We have SSH disabled, removed from the base image, and there is no console access, so to speak, right? Anything and everything that is required for troubleshooting is actually extracted out of the system and is available for troubleshooting and diagnosis. What is the role of AI in cloud technology? I would say AI still has a lot to evolve. I think the first step would be ML, where learnings are used to derive and build constructs which could automate your security space, right? So AI still has a long way to go before ML still has a long way to go, and AI will come later on. Interesting. So Mayank asks, if someone has the encryption key and other than the desired person, then how can he prevent him or her gaining unwanted access? So here's the deal, right? Nobody should have the encryption key. The key management process should be fully automated, and there should be no access into the key store as such, right? So nobody can make an API call into the key store to decrypt keys in the first place, right? Which is where things like parameter store, secrets manager, key management service and all comes into picture. You never let so a human forms the weakest link in the entire security system, right? So as much as possible, put things out there which are fully automated and not dependent on people to generate keys, derive secrets, and all of that. So for all practical purposes, your key store should be so walled that you can only let the application communicate with it for runtime operations only. Admin only knows about the decryption. If the admin leave the organization, there is a 5% chance of data loss. Not really. So as a rule, there should be multiple admins when you start with, right? And even if one admin leaves the organization as a part of the employee exit process, his access should be terminated, and the secondary admin should create new admins who come on board. How much cloud knowledge is required to be a cybersecurity analyst? I would say cloud knowledge is important. It forms the foundation of your knowledge towards, or your pathway towards, cybersecurity. Because unless you know how a system works, it will be difficult for you to protect it, and it will be difficult for you to even ethically hack it. What is really cryptography? So cryptography is nothing but use of keys, which are there are various types of them. There are symmetric, asymmetric keys, and these keys are essentially used to encrypt and decrypt data. Now, the key strength is determined by, you must have heard the term AES 256-bit, and the size of the key determines the levels of encryption that you get, right? There are two things. One is encryption, and the other is integrities, right? So integrities are managed using hashes, right? So there would be a SHA hash, or historically you had an MD5 hash, which will determine that nothing in that encrypted block has been compromised. So two factors. One is something that encrypts it. The second is the other, which is hashing, which will generate a hash for a particular data object, which determines its integrity. So at a high level, in a one line, or in the time that we have for this, cryptography is all about encrypting data and then ensuring that the integrity of the data stays as is. Serverless cloud computing. So serverless runs on servers. A cloud runs on computer as well. So serverless is nothing but time shared access to a shared set of resources, where you run a particular function and you pay only for the time that you spend on executing your function, right? So serverless runs on a shared tenant server. There would be hundreds of users at the same time. So hundreds of these users pool in the amount of time that they get for accessing resources like CPU, memory, disk on it. I'm not an expert on blockchain, so I would have to pass that question. What do build a career in this field? Sorry for that, Manish. So we have the last 2 minutes. What if SSH server is compromised? Very much possible if you put an instance or a Linux instance out there on the public internet and not protect your keys. So SSH server does have a risk of compromise, but like I said, right, keep SSH or management access only to services that do not host or manage data. So as long as you keep SSH restricted to your control plane or your management plane, you will be very well safe for customer or your data in the cloud. What will the size of data increase or decrease while encrypting? No, there is no change in data size as far as I know. Is blockchain and cloud a combination to start a career? Not sure about blockchain, but cloud is a good start to try and learn about computing. Then you could bring in your expertise around programming or whichever stream you would want to go in the cloud. And last, Arvind, is there any breach history in your company? Never, thankfully.
Right. Thank you very much. Thank you very, very much. It was indeed a very enlightening session. I hope the audience over here is going to learn more about it. Thank you. Thank you for your time, Kiran. Thank you.
Thank you.
Yeah.
Bye.
Bye.